Let's slow this down and talk about what this image actually shows. Today, a new processed image of 3I Atlas was shared by Toni Scarmato. The data comes from the Hubble Space Telescope and was captured on January 7, 2026. The observations themselves are not new. What's new is how the inner coma is being examined. Toni makes one thing very clear from the start. These Hubble images have a high signal-to-noise ratio. That matters, because it means the processing is not inventing features out of noise. It is enhancing structures that already exist in the data. He also points out something important. The same structures appear across different processing methods and even in images taken from Earth. That consistency is why he is confident saying these structures are real. Now let's break this image down. First, the left panel. This is a wider view of 3I Atlas, processed using an Unsharp mask. The field of view here is about 1.4 arc-minutes. Unsharp masking boosts fine detail. It increases local contrast and makes subtle brightness changes easier to see. What stands out immediately is stability. The coma is smooth and centrally concentrated. There is no sign of fragmentation, no sign of breakup. You can also clearly see the antitail. An antitail is not a second tail pointing randomly. It is a projection effect caused by viewing geometry and dust distribution. In other words, this is expected comet physics. The key takeaway from this panel is coherence. A stable coma, a defined dust structure, nothing chaotic. Now let's move to the right panel. This is a tighter zoom of the inner coma, about 0.3 arc-minutes. It uses a Larson Sekanina filter combined with Unsharp masking. This technique is designed specifically to study comets. It works by subtracting a slightly rotated version of the image from itself. That removes the smooth, symmetric coma and highlights anything that is not symmetric. And this is where things get interesting. You can see clear, asymmetrical structures near the nucleus. These are not random artifacts. They appear as paired bright and dark features, exactly what this processing reveals when real jets or localized activity are present. Even more important, these structures line up with the antitail direction. That strongly suggests multiple sources of ejecta, not a single smooth outflow. This is where some online claims need to be corrected. These structures do not imply anything artificial. They do not require exotic explanations. They are fully consistent with known comet behavior. A rotating nucleus with multiple active regions can easily produce this pattern. As the object spins, material is released from different surface areas. Once the smooth coma is removed, those structures become visible. Astronomer Drew Doss also shared this image and made an important clarification. He notes that this processing confirms multiple ejecta sources contributing to the antitail. That directly counters claims that try to explain everything with a single mechanism. At the same time, he is careful. He points out that while this strengthens the interpretation, it does not dramatically change what we already knew from earlier images. And that is exactly the right way to read this. So what is the bottom line? This update removes ambiguity. The inner coma structures appear across different filters, persist in independent datasets, and match known dust and jet physics. That is why Toni Scarmato is confident saying these features are real. This is not about hype. It is about precision. Right now, the data shows that 3I Atlas is a coherent, active object with multiple dust emission sources, behaving exactly the way a natural body should under solar heating. It does not change everything. It tightens the interpretation. And that is how good science moves forward.